Hey everybody, you got Mr. C here, and today I'm going to show you a little video on how to complete the square with functions and also why we need to complete the square with functions, with quadratic functions. So let me get started. I'm going to do this first example, and I'm going to let a function f of x equal, and let's do x minus 4 squared plus 3. All right, that function, that quadratic function, is already in vertex form. So the great thing about quadratic functions in vertex form is they're easy to graph because you can tell where the vertex is very easily. The vertex for this guy is at positive 4. Remember, we take the opposite, positive 4, comma, positive 3. This one is as is in the vertex. Now, once you have the vertex, you can just plot that vertex. And then since your a value is 1, you just go over 1, up 1, over 2, up 4, over 3, up 9, and so on. So it's very easy to graph a function, quadratic function, in vertex form. But the problem is, what if it's not? So what I'm going to do is I'm going to take this function here, and I'm going to expand all of this, and I'm going to make it into what we call standard form. So first thing I'm going to do, and I'm going to keep my notation over here, f of x equals, I'm going to expand this out. Now, x minus 4 times another x minus 4, by this point in the course, that should be something we should be able to do fairly easily. And that should give us x squared, and that would be the middle term. 4 times 2 is 8, minus 8x. And then negative 4 squared is just positive 16. That's x minus 4 squared, this guy, plus 3. Now, the only thing else I can do, I can take the 16 and 3 and add them together. And that would give me f of x is equal to x squared minus 8x. And then 16 plus 3 is 19, right? Okay, this is now in standard form. Vertex form, standard form. Both of these have their advantages. The problem, though, is the standard form has a disadvantage, and it's not as easy to graph this guy as it is in vertex form. So one thing we can do is we can put it into vertex form by completing a square, and then hopefully when I complete the square here, I'm going to get this back. So what I'm going to do is I'm going to hang on to this for a minute, and I'm going to write f of x is equal to x squared minus 8x, and then plus 19. The great thing about this is I already know what I need to get at the, as my answer when I complete the square. So I've kind of created a problem that I already know the answer, and this way you can do this, at home anytime you want, and you don't have to have a teacher constantly giving you problems to do. You can just make your own up. All right, so let's do our process. This process is going to be a little different than the equations, though, because this isn't an equation like the other one. This is f of x over here. It's a function, and it's not equal 0 this time. So I got to do things a little bit different. All right, so what I'm going to do is I'm going to say f of x is equal to, I'm going to complete the square on these two guys. So what I do is I write those two terms, minus 8x. I'm going to leave room for a blank, plus 19. Now remember, before I would just add the same thing to both sides, whatever goes into blank. But this time I only have one side to work with. And so if I add this blank to this side to keep everything balanced, I have to subtract that same blank at the end. And this is what my completing the square problems always look like in step number 2 here. So negative 8 divided by 2 squared. That's going to give us negative 8 divided by 2 is negative 4 squared, and that's positive 16. And if you remember, that goes here, and it goes there. All right, now, this is now a completed square, perfect square. So f of x now is equal to x minus 4 squared plus 19 minus 16. Since these are pretty easy, there's no fractions here, I can go ahead and combine them right now. 19 take away 16 is just positive 3, right? So I'm going to put a plus 3 at the end. And then there you go, I'm done. If you rewind the video, you'll see that this was exactly the quadratic I started with. And I can now easily find the vertex, +4, +3. So that works really well. Let me go ahead and let's do another example. This one, I'm going to do f of x is equal to, let's see. And this time let's do a little more complicated, 2 times x plus 5. If you know me, I always start easy, then I get a little more complicated as I go, -6. All right, so this time I've added an extra number up front. Let's see what to do with that. First of all, let me tell you, you can never, do not ever distribute that 2 here at the very beginning. You can't do it. It's a quadratic right here. You're going to get the wrong answer if you do that. All right, so I gotta wait. So what I'm gonna do is f of x is equal to, I'm gonna expand this x plus 5 squared first, keeping the 2 out front. This guy right here is gonna be x squared. 5 times 2 is 10, plus 10x. 5 squared is 25, and then -6. All right, now I distribute my 2 to all 3 of these terms. F of x is equal to 2x squared plus 20x, and then plus 50. And then -6 also. The only thing I can do here is, again, clean up this constant. And so I've got f of x is equal to 2x squared plus 20x. And again, I'm left-handed, so I've got to manipulate everything here. And then 50 take away 6 would be +44. All right. So I'm looking at all of this, and that is what I'm going to use to complete my square to get this back. All right. So I'm going to put that over here. I'm going to take this one. Okay, I'm going to start with f of x is equal to 2x squared plus 20x plus 44. All right, so a lot of math has to do with structure. If I look at the structure here, I'm seeing everything with a 2 in there. 2, they're all divisible by 2. Normally I would take that 2 out. I'm gonna hold off for now and see what happens. All right, I'm just gonna hold off, maybe pretend like I forgot to do that, and let's see what happens. I need to take these 2 terms, and I need to take the 2 out of these 2. I'm gonna leave the constant alone, but I definitely have to get this 2 out of this and take a 2 out of this, because remember, I just want an x squared to complete my square. So here's what it's gonna look like. 2 times x squared plus, okay, if I take a 2 out of 20 by division, that's gonna leave a 10x. And just remember, 2 times 10 is 20, plus my blank, plus 44 at the end. Okay, now I'm adding a 2 blank here, 2 times blank, so I need to subtract a 2 times blank at the end. That's what people always forget. Now let's see what goes into blank. All right, 10, that number, divided by 2 squared equals 5 squared equals 25. So it looks like we have a 25 in the blanks. So 25, 25, all right? This is now a perfect square. So here we go, f of x is equal to 2 on the outside. Perfect square is x plus 5 squared. And let's see, 44 minus 2 times 25. I'll go ahead and write that here just to show this step. Minus 2 times 25. So I've accomplished what I needed here, and I got my 2 back. That's good. And now I just need to look at my constant to make sure I get that correct y-coordinate of the vertex. So f of x is equal to, and math is a lot of rewriting, I found in my many years. You just have to get used to it. 2 times x plus 5 squared plus 44. And then 2 times 25 is 50, so minus 50. All right, so 44 take away 50 would be what? 44 take away 50, so that would be what, -6, I believe. So f of x is equal to 2 times x plus 5 squared minus 6. And if you rewind the video, you'll see that that was exactly the quadratic function that we did start with. And so I got it correct. The vertex this time, because that's the whole reason why we're going to do this, really. We're translating from one type of this function to the other, from vertex form to standard form, and then back again. The vertex would be at -5, comma, -6. And now it's easy to graph. That 2, what that means is, instead of going over 1 up 1, you go over 1 up. 2 times 1 is 2. Instead of going over 2 up 4, you go over 2 up 8. And then you can graph it very easily. All right, that's example number 2. We got one more to go. This is going to be the toughie. So this one's going to take most of my attention here. So let's see what we got. And I'll probably have to slow down. This time, f of x is equal to, okay, here it comes, the dreaded fraction. 1/2 x minus 1 squared, and then -7, let's do. All right, yeah, I know there's a fraction there. We're gonna have to deal with it. So let's go slow and let's see if we can get that back after we expand it. All right, let's expand it. F of x is equal to 1/2 times x minus 1 times another x minus 1 is x squared minus 2x, and then plus 1, minus 7. Now I'm going to multiply or distribute the 1/2 to all 3 of these terms here. And now I have 1/2 x squared. Okay, 1/2 times -2 would just be -1 or just -x. 1/2 times 1 is just going to be plus 1/2. And then minus 7 at the end. Okay, now all I have to do is just combine these two constants. So f of x is equal to 1/2 x squared minus x, and then 1/2 take away 7, -14 plus 1 would be -13 over 2. See, it helps to know those little 5th and 6th grade facts to make my life easier, if you could say that. This is now what I have to work with. All right, so this should be interesting. Okay, here we go. So don't erase that. F of x is equal to 1/2 x squared minus x minus 13 over 2. Okay, so it's gotten a little more complicated, so I'm going to have to go slower to make sure that I don't mess up. All right? So here we go. First thing I need to do, take these two terms, and I need to get that 1/2 out. So f of x is equal to, okay, 1/2 times, there's my x squared. If I take a 1/2 out of this, I'm probably going to have a, what do you think, what would be a -1? 1/2 times what number is -1? Well, sometimes that's hard to figure out. So over here on the side, you could do this. 1/2 times what number equals -1? If you divide both sides by 1/2, the question mark, what number is equal to -1 divided by 1/2? Well, that's really just -2. So if you ever want to find a number that way, it's a little scratch work on the side. I just now found out that it's -2. So let's check. 1/2 times 2 is definitely 1, and then make it negative. That's -1x. So I get what I started with. And then I got my plus blank minus 13 over 2. Okay, now I'm about to introduce here a 1/2 blank into the problem, and so I need to subtract a 1/2. Now I got to erase this part because I don't really need this anymore, and it's starting to creep over there. All right, so now I'm going to introduce a 1/2 blank, but I'm going to subtract it over there. All right, so here we go. First thing, -2 divided by 2 squared is going to be -1 squared, which is 1. So I got a 1 in the blanks. Okay. Down here now, I have f of x is equal to 1/2. This is now a perfect square, and it is x minus 1 squared. All right, so up here now is my constant, negative 13 over 2, and then minus, luckily that's a 1/2, because 1/2 times 1 is 1/2. All right, so now here's what I've got. Negative 13 over 2 minus 1 over 2. That's going to combine to give me a 14 over 2, negative 14 over 2, and that is going to be a negative 7. So here it comes, f of x is equal to 1/2 x minus 1 squared. And then, again, negative 14 over 2 is negative 7. And is that what I started with? It is. Awesome. So now my vertex is going to be at positive 1, comma, negative 7. And although it looked really complicated up here, it turns out to be something very nice, and it is exactly what we started with. And that is how you turn standard form into vertex form and vertex form back into standard form for quadratics. All right, thanks a lot. I appreciate it. And hopefully you use this video and you guys will be able to solve some problems. So until next time.